Now let us discuss the utility theory. So far, we have assumed all decision makers are rational without psychology effect. In reality, we are all human beings and we have all psychology effects. If we consider the psychology effect, the highest EMV might not be the most desirable decision for us. For example, in this example, we have decision A and decision B. We have two states of nature, 1 and 2, and we have the payoff table, $150,000 for decision A in state of nature 1, negative $30,000 for decision A in state of nature 2, and $70,000 for decision B in state of nature 1, and $40,000 for decision B in state of nature 2. We have 50% of the chance in state of nature 1 and 50% of the chance in state of nature 2. If we use EMV approach, we are going to get 60,000 EMV for decision A, and we get 55,000 for decision B. We are going to find the highest value out of these two EMV, so decision A will be our optimal decision. However, if I'm going to let you make the decision by yourself, and I bet that some of you might choose decision B over decision A, because you have 50% of the chance to lose $30,000. In this case, we start to incorporate your risk preference into the decision making. Because most of us are risk averse, we try to avoid the big loss in decision A if we happen to be in state of nature 2. If we try to describe the relationship between utility and payoff, we can categorize into 3 subcases. The first one we call risk averse, and that is denoted by this upper curve. And the bottom one is for the risk seeking. It means you prefer to have more risk. And the middle one is the risk neutral. You are neutral to risk. It means the risk will not affect your decision. Actually, we can use an approach, try to figure out what is your utility function. Now let's try to play a game. We assign utility value of 0 to the worst payoff and 1 to the best payoff. For example, we have utility of the negative 30,000. That is the worst payoff in the previous example. And we assign the utility of this to 0. The utility of the highest payoff of 150,000 to be 1. Now let's try to play this game. We are going to find the utility associated with the 70,000 payoff. So you have 2 choices right now. In the first choice, you want to receive $70,000 with certainty in cash. But in the second alternative, you want to receive 150,000 with probability P, and you lose 30,000 with the probability 1 minus P. You cannot change alternative 1, but in alternative 2, you can change your probability. For example, you can pick P equal to 0.1, P equal to 0.2, 0.3, 0.4, and 0.9, and so on. You want to identify your ideal P that you are indifferent between these 2 alternatives. In other words, the 70,000 in cash is equivalent to the alternative 2 that you get $150,000 with probability P and lose $30,000 with the probability 1 minus P. I believe every one of you are going to have different P values. I'm going to randomly pick a value. For example, suppose someone have a P value equal to 0.8, and we can compute for the utility value of $70,000, which is equal to the utility of $150,000 times 0.8 plus the utility of negative 30,000 times 0.2. Because we assign utility of 150,000 to 1 and utility of negative 30,000 to 0, we have 1 times 0.8 plus 0 times 0.2, we get 0.8 for the utility of $70,000. However, if we compute the expected value of alternative 2 with p equal to 0.8, we are going to get 150,000 times 0.8 plus negative 30,000 times 0.2, we get $114,000 in our expected value. And we know this value is much higher than the $70,000. In that case, we can tell that the decision maker is risk averse. And actually, you can plug in your p-value and compute your expected value of alternative 2. As long as your expected value is higher than $70,000, your risk preference is risk averse. Of course, if your expected value of alternative 2 is lower than $70,000, it means you are risk seeking. If we play the game multiple times, for example, if we pick another value of cash values 40,000, and we can get another p-value, and we can continue on the game for multiple times, we can draw a curve like this. And this curve shows us that we are risk averse if we have a curve like this. In the game, we have $70,000 in cash in the alternative 1. We call this 70,000 as certainty equivalent because we receive this with certainty. For the alternative 2, we receive expected value of $114,000. The difference between 114,000 and the 70,000 is the risk premiums. In this case, will be equal to 44,000. We call this 44,000 as your risk premium. You can think about this case. Suppose you are going to purchase an insurance. That $44,000 will be the maximum amount of the money you are willing to pay for the insurance. So actually, it's a very high risk premiums for you. Now let's go back to the original case of decision A and B with the state of nature 1 and 2. We know that we have EMV of 60,000 for decision A, so we choose decision A as our optimal decision. But if we translate into utility, we are going to have utility of 1 for decision A in state of nature 1, and 0 for state of nature 2, and we get 0.8 for decision B in state of nature 1, and 0.65 for decision B in state of nature 2. Similar to the way of obtaining EMV, we can get the expected utility. If we use 1, the utility of decision A in state of nature 1 times 0.5 plus 0 times 0.5, we get 0.5 expected utility for decision A. Similarly, we can get 0.725 expected utility for decision B by multiplying 0.8 times 0.5 plus 0.65 times 0.5. And we know that 0.725 is higher than 0.5. So the optimal decision is decision B if we use expected utility. This shows that if you consider your psychology effect, your decision under expected utility could be different from your decision in expected monetary value. I would like to provide a couple of comments for you. Although you are the decision maker in your company, but your risk preference definitely is not necessarily the same as your company's risk preference. So as a manager or CEO of your company, you need to take your risk preference into consideration. And it's very important for you try not to be too risk averse in your life. If you are too risk averse, you are going to lose many opportunities. Thank you.